speaker in this session is going to be Ulrich Mayer. Uli is from Earth, Ocean, and Atmospheric Sciences, and he's going to talk to us about biodegradation and ethanol-blended fuels in the subsurface, need for genomics and field experimental studies. And this also is a
Thanks very much for the introduction. Very important because I'm not a microbiologist. I'm a hydrogeologist working in the fields of hydrogeology as well as geochemistry. And what I really want to do is introduce you to some of our problems that we're dealing with, looking at like spills, for example, of ethanol-blended fuels, and also like then provide our perspective towards that, and like talk about the need for like genomic studies in the field of hydrogeology, especially contaminant hydrogeology. So what you see there on the background is like a derailment of like a train which carried like ethanol-blended fuel, so 95% ethanol in nature, and then that's built into the subsurface. And as you can imagine, there's a whole bunch of like different reactions which will take place, and most of them will be biologically mediated. So in times where we have like increased demand for fuels, and biofuels are coming up as well, we have storage of fuels, we have spills of fuels happening. No matter how the contaminant gets into the ground, there's roots in the ground, it is a contaminant. And we'll have like a series of reactions taking place, biodegradation reactions really primarily. In some regions we have like biodegradation which is becoming very slow because ethanol has a toxicity towards microbes. In other regions we have like no biodegradation as well, there's just not enough contaminant of the ethanol around. And in other regions we have like a high degree of like biodegradation. And really, biodegradation of fuels is always taking place when you have regular gasoline without ethanol blended into it. However, it's a little bit different now because ethanol is highly biologically available, degrades very quickly, and then some other issues are coming up, such as, for example, the evolution of like highly anaerobic conditions in the subsurface. You can get like significant production of like methane. If there's a building close by, it's possible that you have like the ingress of the methane into the building, and there's a concern under extreme conditions that there could be explosive conditions developing. At the same time, in the fuel we still have like carcinogenic compounds such as benzene, and they degrade much less readily under like anaerobic conditions, and they still can actually then also be carried with that flux of the methane into the building, and then once again you have a carcinogenic compound into the building. So that's just quite the motivation for the study we're just working on right now. And once again I want to highlight all those processes are really controlled by microbes, microbial activity. And traditionally in hydrogeology and geochemistry it was kind of more considered as a black box, but I think it's really time to step ahead and really look what's happening, what's controlling the processes, and how it works. Okay, so I think just in summary here, like in British Columbia, I think there is like ethanol-blended fuel is coming up quite significantly. If you go currently to the gas station, I'm sure most of you are aware, if you get regular gasoline, it will contain up to 10% ethanol very often. Most oil companies, they're interested in using that. If you look worldwide, North America in general, and Europe as well, people blend fuel with ethanol now. If you go to like Asia or China, people blend fuel with methanol now as well, so it's a different aspect. And there's also like other fuel compounds such as biodiesel which are being used, which once again can also likely lead to those like processes in the subsurface. So what we want to find out is really okay, how much methane, etc., is actually generated in those systems. What is the timing of that methane as it kind of like moves up into the buildings, and yeah. So once again, we also want to look at the issue of like benzene and other carcinogens and how they degrade in the subsurface. Okay, so we actually did already some study together with Stephen Hallam. We did the microbiology work on that. There was a field site in Cambria, Minnesota. Once again, it was like a train derailment in that situation. And what we were interested in, like how much methane is actually generated there, and we did some measurements using flux chambers at the ground surface, picking up the methane flux coming out of the ground. And there are some regions where there's very, very significant methane flux is actually coming out. And in the subsequently, we actually went there and we took a section, several cores from several locations at that site and passed them on to Stephen for like processing in his lab. And what came out of this, the genomic analysis, looking at like DNA as well as like RNA sequencing, that the activity of the rare biosphere increased substantially, and also that there was like very substantial network interactions which evolved over time because of exposure to that fuel spill. So it's a very significant change in like subsurface microbial ecology, and that really promoted like additional motivation to look at that problem in a little bit more detail. So what we really want to do with the study right now is we want to look at how does the function, connectivity, microbial communities evolve over time, what's the evolution of the microbial ecology as a function of the fuel spills, different fuel types. We'll be looking at ethanol, methanol, as well as biodiesel in that study. We want to find out how that affects the rates of like methane production, and in particular the timing of the methane production. There have been sites where people went to the site, they went to monitor the site, and they found no methane at all, like maybe a year after the spill, and then they went back later, another 6 months later, and all of a sudden there was substantial amounts of methane to be found at that site. So there's some shift in community structure in the subsurface that actually causes this. And we hope that this study actually will help us to develop then more effective like monitoring tools, and then looking forward that has like direct impact on like ecological and health-related consequences of the spills, and will help us to understand those better. Okay, so the current project is really a lab-based project. We're running those labs in the environmental interfaces laboratory, or this experiments in the environmental interfaces laboratory at UBC. So we have a series of column experiments where we're looking at the fate of methanol as well as ethanol-blended fuels in different sediment types, at different like fuel gasoline mixtures, and we'll take out like samples along the depth of that column to see how the microbial communities would evolve as a function of the composition, but also over time. So we do like a transient sampling and see how things evolve over time. So that is really the focus of that study. So if you want to find out how does the microbial community evolve over time, you want to find out more about microbial population dynamics, once again, space and time, and then like look at the environmental factors which control microbial ecology. For example, things may happen different if there's more methanol around, things may evolve in a different way in a silty soil as opposed to like a sandy soil, where like you have a different substrate you actually start out with. Okay, I want to highlight that this really is a partnership program. There's been a lot of interest from like a number of like industry. Also should mention like we have like a strategic grant from like NSERC to run this project, and so strategic grant from NSERC to run this project. Industrial partners are actively contributing money to this, like Shell, as well as like API, the American Petroleum Institute. We also get input from other industry partners. API is really like a consortia, which is connected to all kind of like major oil companies, including, for example, BP as well. We're also like involved with like a number of like regulatory partners, like looking at contaminated site regulation, the BC Ministry of the Environment. They're all interested in those aspects, particularly related to the solvent pollution issue I mentioned earlier on. And yeah, that's really all I wanted to say. Just give you an introduction to that problem from the perspective of a hydrogeologist. Thank you.